Welcome to Horizon Smart Factory 2021. My name is Colin Flynn, and I'm going to be the host for today's event. Today we're going to be looking at our AGV transport and book production solution in collaboration with RMGT. As we all know, it's very difficult finding skilled workers, which makes the skilled workers that we currently have more important than ever. We want to make sure that those skilled workers are performing the most value-added, complicated tasks possible and not wasting their time on repetitive, simple tasks such as transporting of sheets from printers to our downstream finishing devices or scanning book blocks and feeding them into a binder. During today's show, we're going to demonstrate how we can use both robotic technology and automated guided vehicles to drastically reduce the number of touch points in a total production flow from our delivery section on the printing press all the way through to delivery on our three-side trimmer producing our finished books. So our first stop today is we're going to go visit our friend Hayashi-san from RMGT, who's going to give us a presentation about our configuration here today. Hayashi-san, please.
Okay. Hi everyone. We are Ryobi MHI Graphic Technology Limited. Here is AGV Automated Sheet Transport and Book Production System Corner and RMGT's AGV Transport Printed Sheets between offset press and book production system. RMGT is a company who does manufacture, sales and service of offset press all over the world. We are continuously challenging to realize factory automation and labor savings, not only for offset press, but for total printing process by using robots, AGV and so on. This is image diagram of RMGT Smart Factory. By utilizing the AGV, papers are transported automatically from warehouse to the feeder of offset press. Plates are transported automatically from CTP system to each printing unit. And printed sheets at the delivery of offset presses are transported automatically to next process. Furthermore, we are proposing to create a factory where products are transported while machines, people, and robots collaborate in the subsequent processes. Under such a smart factory concept, we would like to introduce RMGT's AGV system collaborated with Horizon holding machine and perfect binding machine shown in the slide. Let me briefly explain the flow diagram. All papers are identified by data matrix code printed by inkjet printer at the feeder. During the printing process, inline printing quality inspection system called PQSD inspects all printed sheets and link the inspected data with data matrix code. After printing, Press Information Edge sends command to AGV to transport printed sheets to next process. After receiving the command, AGV transport printed sheets to the feeder of holding machine in condition that OK sheets and NG sheets are mixed on the pallet. Holding machine has a tracking system as an optional items, and it verifies between inspected data from PQSD and data matrix code. Then, only OK sheet are gone through holding process, and NG sheets are rejected automatically. After the job is finished, operator sends command to AGV to transport OK sheet to next process by the tablet. And AGV transports OK sheet to perfecting binding machine.
Thank you very much, Hayashi-san. Now we're going to go head over to our demonstration floor, and I'm going to ask that we have a picture put up on your screen now to give us an overview of what our layout looks like here today. If we could maybe have that image on the screen, please. Thank you very much. So on your screen, you can see our system workflow. Since we're limited for space, we were not able to have an entire press put on. However, we do have a mock-up of our RMGT press in your upper right-hand corner. After our printed sheets are delivered into that section, the nipper will come, pick them up, and then bring them over to our AFC folding machine. From there, we'll be folding our signatures and having them palletized via a robotic arm. As everybody knows, palletizing is an extremely labor-intensive, hard job that can be easily replaced with robotic technology. Once our pallet is filled, we will have the nipper come once again and bring those pallets over to our MG collating gatherer. This is the first time ever that we're introducing our collating gatherer in line with our 4-clamp perfect binder by utilizing our book block feeder LBF 500. From there, we'll be stacking our perfect bound books before they're being infed to our 3-side trimmer HT300 for trimming down to our finished size. Today, we're going to be using our production cockpit to do our imposition, and then having all of our information go to the press information cloud from RMGT, and tracking our jobs via the IceLink cloud-based network available from Horizon. IceLink will allow us to not only track our jobs via barcodes, but also allow us to see the machine status on all connected devices from anywhere in the world on an internet-connected machine. So here we are now at our nipper station, and I'm once again joined by Hayashi-san. Hayashi-san, please.
This is AGV, named Nipper. It is now in the condition of waiting and stationed in the parking area. And this large screen monitor is the press information edge, which is mounted on the operation stand of RMGT offset presses. The press information edge has various functions to support the operator. Today, we have prepared printed sheets in a mock-up delivery unit of offset press. The printed sheets were printed by RMGT 970 series beforehand, and you can see the data matrix code is printed in this area. Current condition is assumed that we have printed up to 2,900 sheets out of targeted 3,000 sheets. Then let's restart printing from this condition. Now you can see that print counter is counting to nearly 3,000. By the command from the press information edge, the nipper starts to move before planned 3,000 sheets are printed by 60 sheets. Although the nipper can operate by itself, we developed a system to coordinate the operation of press information edge and the nipper and realized efficient auto transportation. The nipper has full safety features, and it can be set to wait before going into the delivery. Operator must perform safety check, and in case there is no problem, send command manually from the tablet. Then, nipper can go into the delivery. The nipper automatically detects the pallet in the delivery with a sensor located at the hook tip. Then corrects the pallet position and pick up the pallet. Then the nipper transports pallet to horizon holding machine. The feature of this nipper is it can lift up to 1 ton. No requirement of magnetic tape such as conventional AGVs. Since using a self-mapping system, it can be introduced to your factory in a very short period, and the driving route can be changed flexibly. It is about the same size as a hand lift, and it can be turned on the spot. So it can be used even in a narrow factory. Now OK sheets and energy sheets are mixed on the pallet, but the nipper transports the pallet direct to the feeder of holding machine. After setting the printing pallet, the nipper moves to the next parking area. The nipper's safety devices are a safety laser scanner on the front side, bumper switches on the front and back side, and emergency stop button on the top. The blue lamp in front of the nipper is designed for the safety of workers in the moving direction. Even there is a worker on the route without noticing the nipper, it will stop automatically like this. And when there are no obstacles, such as workers in front, the nipper will restart moving again. The speed is 1 meter per second. Now, nipper has arrived at the parking area for next process and waiting for the next instruction. Ban-san, please.
Thank you, Hayashi-san. I'm Ban from Horizon International, and I will explain about the Horizon side of this book production system. So, as you already saw, the nipper bring the printed sheets from RMGT press, and you can see the pile of the printed sheet here at the feeding section. So as soon as the press and button, the folder start folding, and pick up the printed sheet one by one. And this time we fold into the 16 pages. First parallel fold, then knife fold, another knife fold, then deliver to the press stacker section. And between the closed folder AFC 746F and press stacker PSX56, there's a barcode scanner here. And what is this barcode scanner is doing? Reading the date matrix code, which is printed on every sheet. So as Hayashi-san explained earlier, there's an image inspection system in an RMGT press, and the Horizon can receive that result of the image quality. So this data matrix data is connected to the image quality, and so according to that result, we reject bad image quality sheets here, and at the end of the line, operator can get only the good quality image sheets before binding. So now you can see the pile of the signatures, and the robot arm is picking up and stuck into the pallet. So this is a robot arm from Yasukawa, and if you already checked our previous sessions, we already had a robot arm system with a couple of solutions, and we use a robot for the feeding, or delivering, helping the delivering. And this time we use this for palletizing. As you know, palletizing, as Corinne said, palletizing is a lot of work. I also sometimes had a backache for the palletizing, but with this robot, you never had a robot never has a backache, never be tired, and never complain. That's really important. And with this robot, you can lift 5 kilograms as a pile of the signature. And this time we accumulate 30 pieces of sheet here. But if you change the setting, you can pile more. And you may think that the movement of the robot is too slow. But this time we slow down the speed on purpose. So you have the safety sensor or fences to protect the workers. You can speed up the speed of the robot, and even you can catch up the maximum speed of production of the folder. So this is all about the folder section, and let me stop the system. So it seems that enough pile of the signature are stuck in a pallet. So let me pass my microphone to the Hayashi-san for explaining the nipper again. Hayashi-san, please.
Okay, so please send a command. When nipper arrives at the pallet pickup position, the pallet is automatically detected and the nipper corrects the insert position automatically, then start to pick up the pallet. As you can see, the pallet to be picked up this time is different in size from the previous pallet, but the nipper can cover up to 3 insertion volume for each type of pallet. So by registering insertion volume data into the nipper beforehand, picking up with different pallets can also be realized. The maximum lift-up amount is 130 mm, and it is set to 40 mm this time. As you can see, it's possible to set on a U-shaped operation map. The pallet with holded sheet has been safely delivered to the operator of perfect binding machine. After completing the transportation work, the nipper returns to the parking area and be a waiting condition. Thank you very much. Ban-san.
Thank you, Hayashi-san. So now we had for the signature just in front of our gatherer MG600. So now for the sheet is already loaded in the MG600 gatherer, and the MG600 gatherer picking up the one piece of the sheet from the each hopper to make the book block. And in this system, we have a double feed detection and also image checking system. So if there's any the long sheets loaded, we can detect it before the binding. And now you can see the book block at the conveyor. And in this green conveyor, the book block are transported to the binder, perfect binder. And from here, it's a bit hard to see the inside the binder. So let me play the animation. So in the screen, you can see the animation. This is a LBF 500 book block feeder. And in the book block feeder, there's a 2 jogging station for the precise jogging and 1 pressing station before feeding to the clamper of the binder. And you can see the perfect binder BQ500, which has a 4 clamper, and the binding. After that, delivery to the stacker. And with this demo, we accumulate 3 books as a 1 pile. And now transport the books to the three knives, one knife, three side trimmer. So you can see the books and the conveyor moving intermittently. And this is our trimmer, HT300. And I said this was a one knife, three side trimmer. So at the feeder section, there is a barcode scanner. And this is not for the sheet tracking, but for the job setup. So according to the barcode on the book, we can set up the machine without any make ready. So now you can see the books are cut 4 edge top and a 4 edge and a bottom. Then you see the first file of the sample at the delivery. So this is a sample we make in this book production system. Okay, so this is all about our book production system collaborated with a robot. And this time we use a robot for the palletizing and also transport from the printing to the folding and from the folding to the binding. But we can also use for the different purpose like feeding to the binder or probably helping the workers at the delivery and bringing the finished books to the shipment. That's also possible. And we showed a system with a robot, but the way of the binding is really simple, and this is a very conventional way. But if you add some technology like a robot, you can add more automation. So we believe that choosing the robot is one of the good options to improve your workflow and make your factory smarter. So thank you very much for watching, and back to you, Corinne.
Thank you very much, Bon-san. So why don't we just take a moment to look at what we were able to accomplish here today. We were able to eliminate not only our transportation from the delivery section of our press over to our folder in your bindery section, but we were also able to eliminate any sort of manual palletizing or stacking of our signatures on our pallet at the delivery section. Now, not only are we saving our man hours, our labor in that section, because robots never get sick, they never take a vacation, and they don't complain, but also robots are going to be much more durable in the long run. We're not going to have to worry about somebody coming in sick or suddenly getting back pains. We don't have to worry about any of the health issues associated with repetitive heavy lifting. From our palletized signatures, once again we eliminated any sort of touch points, bringing them over to our machine gatherer. And this system here, again showed for the first time today, is going to eliminate not only our manual sorting of our signatures, but since we're using our loose sheet book block feeder, the LBF 500, we also have automatic calipering of thickness, we have automatic barcode reading, and automatic jogging as well. So we're eliminating 3 touch points before we even feed them into the clamp, which again is another touch point which we've eliminated. Because we are running in line with our HT300 3-side trimmer, we're also able to stack our books and still receive an accurate count on our jobs thanks to the smart sensing features inside of the trimmer. So today we've been able to see how we can use our automated technology to both increase our productivity, reduce our touch points, and streamline our entire workflow, even when working with traditional printing machines. So thank you again for joining us today. After we say goodbye, we will have a timetable of events which are still upcoming during Horizon Smart Factory. So please get your pen and paper ready to take notes, or you can search for Horizon Smart Factory 2021 on Google to find our official homepage, where we have the full list of events and their registration links. But we also have archived videos of the sessions which have already ended, and you can watch those on YouTube. You can also search for Horizon International on social media, either Facebook or LinkedIn, to find our upcoming event information, or just to stay up to date on the latest in finishing technology. For Horizon International, I've been Colin Flynn. I'd like to say thank you to everybody who joined us here today, for Hayashi-san and Bon-san for their explanations. As always, stay happy, stay healthy, and finishing first with Horizon. Thank you.